Hi, this is John Linneball, and I'm with John Linneball Tutoring, and this is Dr. SAT Love, or How I Learned to Stop Worrying and Love the Test. What we're going to do is we're going to go over a few math problems, including a quadratic equation that models how long it takes something to fall to the ground from a height, and also some combinations and a few other goodies here. So if you like this video, please hit the thumbs up button, please subscribe to my channel, and please click the little bell thingy so you'll know when I come out with new videos. Thanks. So, in case you're wondering where I got the title of this video, I got it from Dr. Strangelove, or How I Learned to Stop Worrying and Love the Bomb. That's a classical satirical movie about nuclear war, the US military, etc., and it's by the legendary director Stanley Kubrick, who would go on to make many critically acclaimed movies. What does this have to do with the SAT? It's simple. Scenes from a classic comedy movie can be used to help you learn things you need to know for the SAT math, writing, and reading sections. Today we're just going to focus on the math, though. So remember, everything, even a movie, is a chance to learn something. How the heck can a movie teach math? Well, I'm glad you asked. At least 3 scenes can be used to teach math in Dr. Strangelove. First of all, the mineshaft gap scene. It's easy to use for a ratio/percentage problem. Dr. Strangelove suggests a high ratio of women to men in a mineshaft shelter to repopulate after a nuclear war.
With the proper breeding techniques and a ratio of, say, 10 females to each male, I would guess that they could then work their way back to the present gross national product within, say, 20 years.
You mentioned the ratio of 10 women to each man.
At least 3 scenes can be used to teach math, as I said before. As we've seen, the mineshaft gap scene is easy to use for a ratio or percentage problem. Dr. Strangelove suggests using a high ratio of women to men in a mineshaft shelter to repopulate after a nuclear war. So, we have a ratio or percentage problem. Here's one. Dr. Strangelove is consulting with General Buck Turgidson regarding ways to survive a nuclear war. Dr. S suggests a ratio of 10 women for every man in the shelter to maximize the repopulation rate in the shelter after the surface is relatively safe to live on. Assuming that Dr. Strangelove's plan was followed exactly, for what percentage of all the people in the shelter would be men before any reproduction, that is, before any babies were born? So here's the answer. The sucker punch wrong answer would be 10%. You'd say, well, there's 10 women for every 1 man, so 1 is 1/10. That's 10% of 10, right? No. The question asked what percentage of all the people in the shelter before any babies were born were men. You would have to divide the number of men by the number of women and men, then multiply by 100%. 10% would be correct if you asked the number of men was what percentage of the number of women before any reproduction occurred. But what I'm talking about here is we would need something like, we have 1 man, and then we're going to divide that by, let's put this on scientific so I can use parentheses, divided by, all right, let's try it again. It's 1 man divided by 10 women plus 1 man, so that becomes 11. So that becomes 0.0909, so roughly 9.1%, not 10%. All right, let's move on to the next slide here. Don't let the SAT get the drop on you. Stick to the projectile. Ha ha ha. Get it? Second, the scene where Slim Pickens' character, Major Kong, rides a nuclear missile to its target makes for a classic quadratic projectile motion problem. If we know how high the bomber is flying and the SAT gives us the formula, we can calculate how long it would take Major Kong to hit the ground. Projectile motion is a quadratic formula, and don't worry, the SAT isn't a physics exam. They will give you a formula for the projectile that's either launched into the air like a rocket or dropped from a height like the bomb dropped from a plane with Major Kong on it. The formula for any projectile shot from near the Earth's surface is going to be h sub t equals minus 16t squared plus v sub 0t plus h sub 0, where h sub of t is the height of the projectile at any given time in feet, where t is the time since launch in seconds, h sub 0 is the height at t equals 0 seconds, that is when we start, and v sub 0 is the initial velocity of the projectile in feet per second. Feet per second, even. All right, so let's plug in the numbers. In Dr. Strangelove, the B-52 avoids detection by flying low to the ground, that is, under the radar. If your plane flies low enough, mountains, trees, buildings, and the curvature of the Earth make it hard for radar to detect you or your plane. Let's assume the B-52 is at 3,000 feet, less than a mile above the ground, and at the level of small mountains we see in the background. The initial speed of the missile and height at detonation, we need to put that in. The missiles are set to detonate at height equals 0.
Detonator set to 0 altitude.
Detonator set to 0 altitude.
And we can see that in the movie. And in the movie, the missiles aren't moving at all in the vertical plane. They're not going up or down. They're just moving at the same speed as the B-52 in the horizontal plane, but we don't care about that. So let's plug in the numbers and solve. First of all, we want h of t to be equal to 0 because it's going to detonate at 0, and we need to find t. Since h of t plus v sub 0 of t plus h sub 0, we know that 0 is equal to negative 16 squared plus 0 because there's no velocity. These things aren't moving relative to the plane. And plus 3,000 because we're at 3,000 feet. So if we add 16t to each squared, this cancels out the negative 16t squared, so we end up with 16t squared equals 3,000. If we divide each side by 16, then we see we can get 3,000 over 16, which is 187.5. Take the square root of that, it's 13.693, blah, blah, blah. Okay, we're just going to leave that as 13.69 seconds.
Where in hell is Major Kong?
All right, so now that we've figured out the value of t at 13.69 seconds, we can move on to an essential counting or probability problem. In a pivotal scene, our heroes discover the deranged General Jack D. Ripper, USAF, has ordered an unauthorized nuclear strike on the Soviet Union. The planes can't be recalled without a code of 3 letters. So we can make this into a counting problem where we say the SAT can ask, General Ripper has set a prefix of 3 letters. He dies before he can tell anyone the code. The Air Force desperately needs to find the code. How many different codes would the Air Force have to try to be sure they guess the right code? First of all, you have to assume you have the worst possible luck. You'd have to guess all the codes, also known as brute force. Most computer systems won't let you do that, such as passwords for websites, ATMs, etc. They'll shut you out after a few attempts with a little message saying, your account has been locked for security purposes. Please dial this 800 number or do something else to get it reset. So, the code looks like letter, letter, letter. The counting principle tells us to multiply by the number of possibilities for each slot or place by each other. So, since we know there are 26 letters in the English alphabet, A to Z, and of course there are 10 digits, 0 through 9, that means there are 26 times 26 times 26 possible combinations of the letters in the prefix. And then, obviously, you could add digits at the end, and every digit you add would make the number of combinations increase by 10. So if you 26 times 26 times 26 would be the prefix, and you could multiply, you could add a digit at the end and then multiply that by 10 or 2, then make 100, etc. But we'll ignore the digits for now. That's 26 to the third, which is 26 cubed, which is 17,576 combinations. Using 1964 technology, according to the movie, it would take about 2.5 days to cycle from AAA to ZZZ. The prefix turns out to be OPE, which stands for Our Precious Essence. Also notice that the chances of just randomly guessing the correct prefix would be 1 in 17,576, and that would be 1 divided by 17,576. Okay, so that would be 5.68 times 10 to the negative 5. So really, really small. That would not be one way. You would not be likely to guess that.
Peace on earth. Peace on earth. Peace on earth. P-O-E. Purity of essence. O-P-O-E. O-P-E.
All right, here are a couple of problems we could base on the prefix problem. So let's assume General Turgens's estimate is correct, and it would take 2.5 days for them to go through all the combinations. Yes, I see it says them 2 through. Sorry, made a mistake there. The SAT might ask you how many seconds it would take to transmit each 3-letter prefix. First of all, we'd have to take 26 to the 3rd power, as we did above. Most likely, this would be on the calculator section of the SAT, and you can use a calculator on all of the ACT, so that should be child's play for you. Even with a 4-function calculator, you know, like something you might just take shopping, you could just input 26 times 26 times 26 and get the answer. In fact, we'll do that. Here, let's set it to standard and go 26 times 26 times 26, boom, 17,576. All right, let's switch this back to scientific. And the next issue is also easy. If you have to figure out how many seconds are in 2.5 days, it's not that hard. You just multiply 2.5 times 24. 2.5 times 24, that gives you 60. Then you want to find out the number of hours, so you just multiply that times, the number of minutes, so you just multiply that by, okay, you get 60 hours. Here, let's start again. Okay, yeah, 60 hours in 2.5 days. Multiply that by 60 minutes per hour, that gives you 3,600 minutes in 2.5 days. Multiply that by 60 to get seconds, and you have 216,000 seconds. And then what you want to do is you would just divide that by by the previous thing, which is number of seconds. So then, we would just go and divide 216,000 by 17,576, and voila, so it's about 12.29, seconds per prefix. So let's just round that to 12.29 seconds per prefix. Okay, so this problem could be followed by something like, given the time per prefix, and assuming the prefixes were transmitted in order from AAA to ZZZ, such as AAA, AAB, ABC, ABA, ABB, ABC. How long would it have taken the Air Force in days to the nearest tenth of a day to finally transmit the prefix OPE? Well, we know O is the 15th letter of the alphabet, so we would go through 14 times 26 times 26 combinations before we reached OP or OAA. So we're going to go 14 times 26 times 26. So that's 9,464. And then to get to OPA, we'd have to go through another 15 to get from A to P times 26 combinations to get to OPA. So that's going to be plus 15 times 26, which is 9,854. And then we'd have to add 5 because that would get us to would get us to actually the one right before OPA. It'd be OOZ, and then you go OPA, OPB, OPC, OPD, and OPE. So then we add 5 to that, so we get 9,859 prefixes, including the correct one, OPE.
This is SAC Communications Control. The recall code OPE is being acknowledged Roger by elements of the 843 bomb wing. These are the details. Missions 12, 22, 30, and 38 are reported destroyed by enemy action. All other missions have acknowledged recall code.
All right, are we done yet? No, we are not, because we still don't know how much time that would take. So are we done yet? Nope. Finally, we'd have to multiply 9,859 prefixes times 12.29 seconds per prefix. So that's going to be 9859 times 12.29. So that would give us 121,167.11 seconds. Then we have to divide that by 60 seconds per minute to get minutes. So it's 2019.4518333333 minutes. So then we need to divide that by 60 minutes per hour to get hours. So voila, we get 33.65753055555556. So roughly 33.66 hours, which if we divide that by 24 hours per day to get days, we get roughly 1.4 days. So that's your answer, 1.4 days. And if you'd like to know more about Dr. Strangelove and Could It Happen, you can go to the New Yorker's website and look up newyorker.com/news. News has almost everything in Dr. Strangelove was true. This is a very thought-provoking article in the New Yorker about the frightening accuracy of Dr. Strangelove. And you really should see this movie if you haven't. It's a true classic by the late, great director Stanley Kubrick. His movies are easy to stream, find online, or rent or buy on DVD at low cost and well worth seeing. Some of his other movies include Clockwork Orange, The Shining, and several others, 2001: A Space Odyssey. Those are all good movies to see. We'll meet again. Please comment on and thumbs up my video. Please subscribe to my channel if you like this content, and please let me know if you didn't. I'm a huge fan of constructive criticism, emphasis on constructive, and we cannot have a YouTube gap. Please watch my other videos and click on the bell icon to be alerted when I make new videos. All right, have a good day, night, whatever time it is there. Bye.
Monsieur! I can walk!
We'll meet again